So we are starting with arrays. Today's topic is array. We will cover arrays today. Okay. Array through we will cover arrays through some important questions. Arrays through important questions. Okay. Let's see what is our first question. This is our first question. Let's see what the question is saying. So the question is to find, let's read the question. Largest subarray with zero sum. Given an array ARR containing both positive and negative integers, the task is to find the length of the longest subarray with a sum equals to 0. A subarray is a contiguous part of an array formed by selecting one or more consecutive element while maintaining their original order. Means, suppose if we take the example, the array is 15 minus 2, 2 minus 8, 1, 7, 10 and 23. In this array we have to find the largest subarray with sum 0. We can see this subarray has a sum 0 and its length is 2, and this subarray also has, this complete subarray also has sum 0 and the length of this subarray will be 5, which is our required answer. See, 5 is the required answer. We need to find this for any given array. Like in this example, no subarray has a sum 0, so we are returning 0. In this subarray, in this given array, this subarray has sum 0. Also, we can include these two zeros also, which makes length equals to 5, which is our required answer. So how we are going to do this? Let's think how we can solve this. Let's go to R. First, I will explain you all the approach, how I am approaching the question. This is longest subarray with sum 0. This is my first question. Let's take an example like 15 minus 2, 2 minus 8, 1, 7, 10 and 23. Approach. My approach will be like, suppose I have a random continuous part of array starting from 0th index to any index I. Okay, and suppose this part of array has some x, and suppose I want a sub array whose sum is equals to k. So to find that, I will see that is there any sub array starting from 0th index, any sub array starting from 0 index whose sum is x minus k. I will check while traversing from this side to my complete array. I will check is this exist. I will take a map and I will check is sorry I will check in the map dot find x minus k. If we have any subarray with sum x minus k, that means we have a subarray with sum k. How we are going to do this? We will keep a map of int comma int that will store prefix sum with its count. Not count. Prefix sum and first occurrence of that sum. Let's take this example to see how this will work. Let me take a variable sum, initialize it with 0. Also take an answer variable and initialize it with 0. Okay. I am starting from 15. Okay. I will add 15 to sum 15. and I will check. And one more thing I didn't mention here, in this question we have k equals to 0. So what will be k minus x minus k? That will be nothing other than the x. So each time we will search for x, if we have seen x before or not. If we have seen x means here we have 0. This sub array has a sum 0. So we came to this index and we have added this element 15 to our variable sum. Now we will check if sum is equals to 0 or not. If it is 0, then I will update my answer to maximum of answer comma I plus 1. And if map dot find of this sum is not equals to map dot end, this, what does this check means? This check means that is there any subarray starting from the index 0 that has sum equals to sum, and which will make sure that the remaining portion, that is the remaining subarray, has a sum equals to 0. This is what we want to check. So let me clear it first. If this condition is true, then what we are going to do is we will update answer to maximum of answer comma current index minus the first index where we saw this sum. Otherwise else we will store this sum with value I, that is I is the first index where we saw this sum. At last we will return our answer. This is our pseudocode. So I think it is clear. So let's code it up. Array dot size sum equals to 0, answer equals to 0, unordered map int comma int for int I equals to 0, I less than n, I plus plus. Sum plus equals to arr dot I if sum equals to 0, then answer will be maximum of answer comma I plus 1. In fact, we can remove this max condition also, because let's see this. I forgot to mention that point. This check, this one, this check, sum equals to 0, it is making sure that as we are traversing this array from left to right, at any index I, my current sum is equals to 0, and this is the longest part of the array that I have seen so far. So there can't be any subarray that I have seen before this which has length larger than this. Means no subarray can have length more than I, other than this. This is what I'm trying to say. So we can remove this check also. We are keeping it for the sake of just to make it look complete. Otherwise it is not necessary to keep. I will check map dot find this current sum is not equals to map dot end. That means I have a prefix sum equals to sum, and that makes sure that I have a subarray with sum 0. So answer will be maximum of answer comma I minus map of sum else I will keep this with the current index, and at last I will return the answer. Let's check. Let's submit. Yes, we got the correct answer successfully. Now moving to the second question. What is the second question? Let's see. This is our second question. I am giving you time to read this question and coming 5 minutes. So I hope you all have read the question. Let me also read this question, what it is saying. Oh, I need to put my laptop on charge. The question is saying, given an array nums with n objects colored red, white, blue, sort them in place so that the objects of the same color are adjacent with the colors in the order red, white, blue. We will use the integers 0, 1, 2 to represent color red, white and blue respectively. You must solve this problem without using the library sort function. Okay. We will not use sort. Also, we will not use any extra space. We are going to solve this question in big of n, time complexity, and space complexity, big of 1. So actually, to solve this question, I will write that on notebook that there. To solve the second question, that is sort array having zeros, ones, twos. To solve this, we are going to use an algorithm known as DNF algorithm, that is Dutch National Flag algorithm. let's take an example array to understand how this algorithm works. Let's take the array as 2 0 2 1 1 0. This is our given array, and the output array we expect as 0 0 1 1 2 2. This is what we expect. This is what we are expecting. How we are going to do this? For this, I am going to take 3 pointers. Left, mid, right. This will be initialized with 0, this will be initialized with 0, and this will be initialized with n minus 1. How we are going to do? Let's copy this array to see that. So here is my left pointer, here is my right pointer, and here is my mid pointer. So I will check if my array at mid is 0. If it is 0, then what I will do, I will swap my array at L with array at mid, and I will do L plus plus and a mid plus plus. Because we want all the zeros here, all the twos here, and ones in the middle. Else, if array at mid is equals to 2, what we will do, we will swap it with array at R, array at mid. We will do a right minus minus. Otherwise, I will simply do a mid plus plus. And this will be done. Now let's dry run this algorithm on the example we took to understand this more clearly. my array at mid is 2. In this case, what we will do, see here, we will swap this with mid and do a r minus minus. Means here we will have a 0 and here we will have a 2. Now my array at mid is 0. And in this case, what we do, we swap it with L and increment both the pointers. So L and M are pointing to the same index. We don't have to do anything. We just increment L and M. Now my M is equals to 0, array at M, and both the pointers point to the same index. We don't have to do anything. We will just simply increment both of them again. Now my array at M is 2. In this case, what we do, after swapping we didn't decremented it. We have to decrement it. So here, now my array at M is 2. In this case, what we do, we swap it with array at R, and we decrement R pointer. Now my array at M is 1. If array is at M is 1, we don't do anything. We simply increment our M pointer. Okay. My M is again 1, and in this case also I don't have to do anything. Now see here, my mid has crossed this right pointer. Whenever my mid goes beyond R, we will stop. Means all this procedure I have to do while, let's skip it with the other code only, that will be helpful. Means all these checks will be done inside a while loop, while M is less than equals to R. I hope the concept is clear. So let's move to the code. Int n equals to nums dot size. We are storing the size of num here, and then we will take our 3 pointers. L equals to 0, M equals to 0, R equals to R n minus 1. Okay, while M is less than equals to R, we will check if nums at M equals to 0. If it is equals to 0, then we will swap nums at M with nums at L we will increment L, we will increment M also, else if num set M equals to 2, we will swap num set M with num set R, and we will decrement R by 1, else we will simply increment M by 1 and nothing else. Let's see. It should pass all the cases. Now let us move to the third question without wasting any time. Majority element. This is also a very important question. Let me take a clear page. Oh, I forgot to give you time to read the question. As we have less time, we have to complete a total of 7 questions today. I am reading it quickly. Given an array nums of size n, return the majority element. What is the majority element? Majority element is the element that appears more than n by 2 times. Imagine that the majority element always exists in the array. We need to find the element which is occurring more than n by 2 times. How we are going to do? Third question. Majority element in array. How we can do this? To solve this question, we will use a very famous algorithm known as Moore's voting algorithm. This is a very famous algorithm. How we will use this? Let's see. We will have a integer count and an integer element. Suppose I have a array 2 2 2 1 1 1 2 2. So initially what I will do, I will initialize element with the first element of the array and count with 1. Actually this count is storing the number of occurrence of EL over other elements. Means how many times EL has occurred over other elements. Let me run this algorithm on this example. It will be clear. So I have initialized EL with 2 and count with 1. Okay. Now I will move my pointer to the next element. This is 2. So if, writing my first condition, if current element is equals to our element, then we will increment the count and we will not change the element. So we will just increment the count. Moving to the next 1. So our next condition is else decrement the count. If we saw any element other than the element EL, we will decrement the count. So our count will become 1. Moving to the next element 1. This is also not equals to the EL. We will decrement count with 0. Again this. Now our third condition, that is written above these two, that is if count equals to 0, we will make EL as the current element and count equals to 1. So here we are having 1 as the current element. 1 is our current element and EL is 2 and the count is 0. So count is 0, so EL will become 1 and count will become 1. Okay. Moving our pointer to next element, which is 2. That is not equals to EL, so we will decrement our count. So our count will become 0. Again moving our pointer to the next element. Here we can see 2 is our current element. Count is 0, so we will make EL as 2 and count as 1. And move our pointer to the next element, which is the end of the array. So here we got 2 at the end in EL, which is indeed our majority element. So this was very easy. Let's code it up. Now start size. We will have two variables, int count, which will be 1, and EL, which will be num set 0. If count equals to 0, EL will be num set I and count will be 1. if EL equals to nums at I, count will be plus equals to 1, else count will be minus equals to 1. At last we will return our EL. What's there here? Let me see what is there here. N equals to nums dot size into count equals to 1, EL equals to nums at 0. Okay, if count equals to 0, oh, I need to keep it in. Else so we did complete our 3 questions. Let's move to the 4th one. We need to find maximum subarray. What the question is saying? Let's read the question. Maximum subarray. Let me zoom it. Given an array of integers ARR, find the contiguous subarray with a maximum sum that contains only non-negative numbers. If multiple subarrays have same maximum sum, return the one with longest length. If there is still a tie, return the subarray with the smallest starting index. If the array contains only negative numbers, return -1. A subarray is a contiguous non-empty subsequence of element within an array. This is kind of cadence, but it has some more checks. Let's see how we can tackle this question. Our 4th question, maximum subarray sum. Let's see how we can tackle this question. Obviously, in this case, we are going to use the cadence algorithm, which is, I guess, the most popular algorithm when it comes to the arrays topic. Most popular and most important also. what are the other checks? Maximum sum that contains only non-negative integers. In Cadence algorithm, we just have to check the subarray with maximum sum. Here we also have to check that the subarray should not have any non-negative element. Also, in typical Cadence algorithm question, we are told to return any subarray with the given sum. But here we have to return the subarray with the longest length. If we have tie, we will have to return the smallest starting index. So a lot of checks will be there. Okay, let's see how we can solve this. Actually, in this question we don't need any. In this question we don't need to use cadence algorithm. It is used for such questions, but this one can be solved without using cadence. Let's see how. Suppose I have a array 1, 2, 5, -7, 2 and 6. Suppose I have this array. Here it is mentioned in the question that the sub array should not have any negative number. That is, wherever we are finding any negative number, that is acting as a divider between acting as a divider in the array. That is, this negative number has divided the array in two parts, this one and this one. What we will do, we will have a sum initialized with 0. We will keep on adding this with the elements we have seen so far, and whenever we are seeing a negative number, we will keep this sum, also this indexes like answer dot start, something like that, or answer dot end, to store this indices, and we will reset this sum with 0. Again we will start from here, 2, then 8, both the sub array has 8, but we will see here the length of the sub array is 2 and here it was 3, and in the question it is given that we need to check, first we need to check the highest sum. If we get a tie in this condition, then we will check the longest subarray. And we also, if in any case, suppose I have the same sum, also both the subarray have same length, then I will check which one has smaller starting index. So this is the priority to decide what should be our answer. Okay. So how we are exactly going to do this? I am going to write the pseudocode, then I will write the full code. Pseudocode. Okay. Let's see. I will have a maximum sum initialized with suppose -1. Answer dot star, answer underscore star initialized with -1. Also answer underscore end initialized with -1. Okay. Then I will also have a sum initialized with 0 to have the running sum. A running sum of elements. Then I will put a loop from I equals to 0 to array dot size. We will check if I is less than array dot size and array at I is greater than equals to 0, then I will add it in my current sum. Array at I we will also keep a bool has negative. Has negative initialized with false. Else condition will be, suppose I have crossed the array, I have crossed the array, or my current array element is negative. In that case, will check if this subarray has negative which we will make actually we don't need this. First of all I need to skip all the negative numbers. While I is less than n, if array at I is less than 0. I will be plus plus and continue. And declare this sum here. We will keep a left with I and sum we have declared 0, while left I is less than n and an array of I is positive. What I am going to do, I will make sum plus equals to array of I, and I will increment I also. I will have a R variable to store where this subarray ended, a subarray of non-negative integers, because I am coming here out of this loop only when I have traversed the entire array or I have encountered a negative number. These are the two possible cases when I have come here. Then I will have a length that will be R minus L plus 1, and I will compare with my best length. I will have a best length that will be if my answer of starting index of answer is equals to minus 1, then this will be 0, otherwise this will be answer e minus answer of s plus 1. If my sum is greater than maximum sum or sum equals to maximum and length, current length is greater than best length. Or sum equals to max and length is greater than best length, or length equals to best length and length, that is L, is less than answer slash S. In this case, my answer underscore S will be L and answer underscore E will be R. Also MX will be sum. At last we will have a check if answer underscore S is still equals to minus 1, and we will simply return an array having minus 1. Otherwise, we will have a array for storing our answer. For this, we will iterate from answer of S to answer underscore E. I will keep on pushing adding array at I, and at last I will return my answer array. this is the complete code. Let me keep it in one frame. Yes, this is the complete pseudocode of our question number. What is the question number 4? So let's code it. First of all, I will take array size in n. First, let's see. Answer underscore s equals to minus 1. Answer underscore e equals to minus 1. Int I equals to 0. While I is less than n, if array at I is less than 0, simply increase I and continue. Int L equals to I and sum equals to 0 while I less than and array at I is greater than equals to 0, then sum will be incremented with array at I. Also I will be incremented by 1. Int r equals to I minus 1, length equals to r minus l plus 1, int best length equals to answer at e minus answer at s plus 1. This is when answer at s equals to minus 1, then you will have 0, otherwise you will have this. Keep it in brackets. Now if my sum is greater than maximum sum, or sum is equals to maximum and length is greater than best length, or length is equals to best length and answer dot s that is greater than L, which is not possible, but still you can keep it. Maximum equals to sum. Answer underscore s equals to L. Answer underscore r equals to r. If best length equals to minus 1, not best length, answer test is still minus 1, then I will return otherwise we will have a vector int of answers for int equals to I equals to answer s I less than equals to answer dot n I plus plus answer dot push back ar dot I return answer. Let's check. Let's submit this code. So it has passed. It's already 4, so we will continue from here tomorrow and stopping the stream.